ஹலோ, டிஃபைன் யூ எலக்ட்ரிக்கல் சேனலுக்கு உங்களை அன்புடன் வரவேற்கிறேன். நீங்கள் இதுவரைக்கும் என்னுடைய சேனலை சப்ஸ்கிரைப் பண்ணலைன்னா மறக்காமல் இந்த வீடியோ கீழே இருக்கிற இந்த சப்ஸ்கிரைப் பட்டனை ப்ரெஸ் பண்ணுங்கள். பக்கத்தில் இருக்கிற இந்த பெல் ஐக்கானையும் நீங்கள் ப்ரெஸ் பண்ணிங்கன்னா நான் புதுசாக வீடியோஸ் அப்லோட் பண்ண உடனே உங்களுக்கு பார்க்கலாம். இந்த டைட்டில் பக்கத்தில் இருக்கிற இந்த ஆரோவை நீங்கள் ப்ரெஸ் பண்ணிங்கன்னா டிஸ்கிரிப்ஷன் பாக்ஸில் நான் ஏதாவது டிஸ்கிரைப் பண்ணியிருந்தேன்னா அதையும் உங்களுக்கு பார்க்கலாம். இது மாதிரி இன்னும் நிறைய வீடியோஸ் வேணும்னா மறக்காமல் இந்த வீடியோவை நீங்கள் லைக் பண்ணுங்கள். வீடியோவை கடைசி வரைக்கும் பாருங்கள்.
Operational amplifier has two input terminals and one output terminals. The two input terminals are inverting input terminal and non-inverting input terminal. Inverting input terminal is negative and this positive is non-inverting input terminal. The ideal op-amp characteristics are open loop gain is infinity, input impedance is infinity, output impedance is 0, bandwidth is infinity and zero offset. Zero offset means when V1 and V2 is 0, output V0 is also 0. So from these ideal op-amp characteristic we can have three properties which can never be realized in practice. Those properties are: it can be seen that an ideal op-amp draws no current at both the input terminals, that is I1 equal to I2 equal to 0 because of infinite input impedance. Any signal source can drive it and there is no loading on the preceding driver stage. Since gain is infinity, the voltage between the inverting and non-inverting terminals, that is differential input voltage Vd equal to V1 minus V2, is essentially 0 for finite output voltage V0. Here this differential voltage Vd equal to V1 minus V2. Next one is the output voltage V0 is independent of the current drawn from the output as R0 equal to 0. The output thus can drive an infinite number of other devices. So the above properties can never be realized in practice. So this op-amp is a voltage controlled voltage source and the output voltage is given by V0 equal to A open loop gain A0 L Vd. Vd is equal to V1 minus V2. So V0 equal to open loop gain into V1 minus V2. Next, in inverting amplifier. So in this inverting amplifier, this is the circuit diagram for inverting amplifier. In this inverting amplifier, the output voltage, this output voltage is fed back to the inverting input terminal through the feedback resistor RF. Okay, this output voltage is fed back into the inverting input terminal through this feedback resistor RF. Then input signal Vi is applied to the inverting input terminal. Okay, input terminal through the resistor R1 and this non-inverting input terminal is grounded. Okay, then the current I1 is equal to Vi by R1. This is the current I1. Next, this output voltage is minus okay, it is fed back. Okay, so minus I1 RF, minus I1 RF, that is equal to minus Vi RF by R1, since I1 is equal to Vi by R1. Then gain of inverting amplifier are closed loop gain ACL. Okay, ACL closed loop gain, that is V0 by Vi equal to minus Rf by R1. This negative sign indicates the phase shift of 180 degree. This negative sign, okay, 180 degree between Vi and V0, replacing R1 and Rf by Z1 and Zf. Okay, here we are replacing Rf and R1 by Zf and Z1. Then we will get closed loop gain as minus Zf by Z1. Next, non-inverting amplifier. Okay, if the signal is applied to the non-inverting input terminal, see, this is the signal is applied to the non-inverting input terminal and feedback is given, the circuit amplifies without the inverting the input signal. Such a circuit is called non-inverting amplifier. It is also a negative feedback system as output is fed back to the inverting input terminal. This is RF feedback resistor. Output is fed back to the inverting input terminal. Next, Vi equal to V0 by R1 plus Rf into R1. Then closed loop gain ACL equal to V0 by Vi equal to 1 plus Rf by R1. Then compared to the inverting amplifier. Okay, this is non-inverting amplifier. Comparing to this with the inverting amplifier, the input resistance of the non-inverting amplifier is extremely large, that is approximately equal to infinity, as the op-amp draws negligible current from the signal source. Please like the video if you like this. Thank you for watching.